You think Tesla already changed the world? No, that was just the tutorial level. Because right now, quietly, invisibly, something far bigger is unfolding. Something that competition hasn't noticed, and you probably haven't either. You see the cars, the badges, the memes. You think that's the revolution. But what if I told you the cars were never the point? What if the Model Y, the Cybertruck, even the cheap Tesla everyone's waiting for, are just camouflage? A distraction, hiding a machine, an ecosystem so vast it doesn't just disrupt industries, it rewrites how energy flows, how factories think, and how work itself exists. Because while every legacy automaker is busy copying moves from 2020, Tesla in 2025 is playing a game no one else can even see. A 5-part master plan that doesn't compete with car companies, it consumes them. And once you understand it, you'll realize we're not watching a car company evolve. We're watching a new era boot up. Before we pull back the curtain, make sure you hit like and subscribe to Dravexa. Trust me, you don't want to meet the future from behind. This playbook has 5 moves, 5 strikes. 1. The unboxed process, tearing down a century of assembly line tradition. 2. The 48-volt architecture, rewiring the nervous system, aiming for ignition. 3. The 4680 cell, the key to cost and range, breaking the restriction. 4. End-to-end AI, the ChatGPT moment for driving, moving past fiction. And 5. Optimus, putting that AI on 2 legs, a machine on a mission. Any single one of these disrupts the game, but all 5, stacked, it's a fortress, an insurmountable lead. Today, we deconstruct the machine. We strip it down. You ready to see what's under the hood? You need to understand the most profound weapon in Tesla's arsenal today isn't a vehicle, it's the factory. Musk calls it the machine that builds the machine. But that's not just a slogan anymore, it's the reality. Enter the unboxed process. For 100 years we've bowed to one king, Henry Ford's assembly line. You know the scene, a metal skeleton, a body in white, crawling down a linear track. It's a slow sequential march. Add the engine, add the seats, add the doors. But that system is fundamentally flawed. It's a dinosaur. Think about the friction. The whole line moves at the speed of the slowest hand. One delay, and the whole world stands still. A total bottleneck. You have robots and humans doing a cramped, chaotic dance, fighting for space inside a steel cage, trying to screw in a bolt without missing a beat. And the line itself? Rigid, unforgiving. You want to change the model? Good luck. It's a nightmare to retool. It's heavy, it's slow, and frankly, it's costing you a fortune. So Tesla's unboxed method throws that entire 100-year-old concept in the trash. Instead of one long, slow line, the factory is organized into parallel processed chunks. Think of it like building a Lego car. You'd never build the frame first and then try to stuff the little driver through the tiny window. It's absurd. You'd build the floor. You'd build the front block, the rear block, the cabin, and then, at the very end, you just click them all together. This is exactly what the unboxed process does. Imagine this. Over in one corner of the factory, that massive front Giga casting is getting its motor, its suspension, its steering. At the exact same time, in another corner, the rear Giga casting is getting its motor. And simultaneously, the central floor pan, which is the 4680 structural battery pack, is being prepped. The real magic? Open access. workers and robots have a full 360-degree attack. You want to install a dashboard? It's simple. There's no roof, there are no doors in the way. It is massively faster, it's more ergonomic. Then, and only then, do these huge pre-assembled, pre-tested modules meet the front, the rear, the painted side sections. They're all joined to that structural pack in one final step. The results? Tesla claims a staggering 40% reduction in factory footprint, a 25 to 30% increase in production speed, all while slashing the cost to build the factory in the first place. This isn't just an improvement, it's a new paradigm. And if you want to follow this revolution, you need to be subscribed to Dravexa. This is the only way Tesla can realistically build that $25,000 car at high volume and, most importantly, at high margin. But here's the secret. That unboxed method, that whole Lego block strategy, is only possible because of another Tesla innovation, Giga casting. You have to understand, traditionally, a car's underbody is a complex puzzle. We're talking 70, 100, even more different stamped metal pieces. All of them have to be painstakingly welded together by a massive body shop of hundreds and hundreds of robots. Tesla's Giga press, a machine the size of a small building, throws all that out. It casts the entire front or rear underbody as a single piece of aluminum. Just that one innovation, it eliminates over 300 robots. It erases 600+ welds. It frees up a massive amount of factory space. The resulting part is stronger, it's lighter, and it is critically, unbelievably faster and cheaper to make. That single Giga part, that is the Lego block that the unboxed method is built on. And this is the part that should make you hit that like button. While competitors are just now scrambling to order their first Giga presses, they're already years behind, because Tesla isn't just ahead in the machine, it has a multi-year lead in the metallurgy, the secret sauce, that special aluminum alloy that is strong, not brittle, and perfectly castable at high speed. That is a deep, costly moat. And for legacy automakers with their billion-dollar investments in those old-world body shops, crossing it might be impossible. So, you have the unboxed skeleton. Now, you need a nervous system. And for over 60 years, the entire auto industry has been locked into a dying standard, a 12-volt system. You have to understand, this 12-volt standard was designed for simple machines, a car with lights, a radio, and maybe power windows. But today, your car is a supercomputer on wheels, and that 12-volt system, it's become a critical bottleneck. The problem is just basic physics. You've heard the equation, power equals voltage times current. If you want more power, say for faster moving seats, a more powerful audio system, or the advanced steer-by-wire you see in the Cybertruck, you have to raise either the voltage or the current. And since the industry has been stuck at 12 volts, their only option was to drastically increase the current. The result? Thick, heavy, expensive copper wires to manage the heat and the load. We're talking about a wiring harness in a modern luxury car that can weigh over 50 kilograms. That's over 110 pounds. It's miles of copper. It's one of the most complex, costly, and manually installed parts in the entire vehicle. Worse, you hit a hard limit. You simply cannot run the high-power systems of the future on a 12-volt rail. Not efficiently, not safely. So, what does Tesla do? They change the equation by moving to a 48-volt system, first in the Cybertruck and now standard on their next-gen platform. They flip the table. Think about it. To get the exact same amount of power, if you multiply the voltage by 4, you can divide the current by 4. That is a profound change. A 4 times reduction in current means you can use wires that are dramatically thinner, dramatically lighter, and dramatically cheaper. And the power you lose as heat? That drops by a factor of 16. The Cybertruck's wiring harness is a fraction of the size of a normal truck's. This saves money, this reduces weight, which increases range, and it massively simplifies that unboxed manufacturing process we just talked about. It's the key that unlocks the Ethernet data bus, where a single cable can finally carry both power and data, destroying the one-wire per function nightmare of the past. But this is the part that should have every legacy automaker terrified, and it's why you need to click that subscribe button for Dravexa. This shift to 48 volts, it's not just an internal change, it is a shockwave to the entire global supply chain. For decades, companies like Bosch, Continental, and Denso have perfected the 12-volt world. All those window motors, the pumps, the fans, they are all 12-volt. By moving to 48 volts, Tesla is effectively making its entire parts list obsolete. Suppliers now have to re-engineer, retool, and revalidate everything. A company like Ford or GM, they can't just switch. They are being held hostage by a supply chain that simply isn't ready. But Tesla? Because they designed so many of their own controllers, their own components, they can force the change. Their vertical integration lets them absorb the complexity. While their competitors, they're left tethered to a 60-year-old standard, adding yet another layer to Tesla's massive manufacturing and cost advantage. So, your factory is fast, your car's nervous system is efficient, but you still have a massive problem. Energy. The car still needs a breakthrough to be affordable for everyone. And that breakthrough is the 4680 battery cell. The name? It's just the dimensions. 46 millimeters wide, 80 millimeters tall. But its design? That is the revolution. You see, a traditional battery, like the 2170 cells in a Model 3, has two little tiny tabs at the ends. All the energy has to fight its way in and out through these two tiny bottlenecks. This creates a traffic jam. It creates massive heat, especially when you're charging fast or flooring it. The 4680's tabless design is pure genius. Instead of a tiny tab, it uses a shingled spiral. This means the entire edge of the battery's internal foil is the connection. The path for the energy is suddenly short, wide, and clear. This one change fundamentally rewrites the cell's properties. First, less heat, drastically less. Second, faster charging. With no heat to manage, you can flood the cell with power. And third, more power instantly. This is the secret to plaid-level acceleration. But that isn't even the real story. If you're enjoying this deep dive, hit that like button for Dravexa, because the manufacturing is the true change everything moment. It's a process called dry battery electrode, or DBE. For 50 years, everyone has made batteries the same way, a wet slurry. You mix the battery materials into a toxic wet paste, you paint it onto a foil, and then you run it through massive 100-meter-long energy-blasting ovens to dry it out. Tesla's DBE process, it stamps the active material dry directly onto the foil. No solvent, no water, no drying. Now, you need to understand how impossibly difficult this is. It is the holy grail of battery manufacturing. It's the main reason the 4680 ramp-up was so slow. The old wet method is like painting a wall. It's slow, but the paint spreads evenly. The dry method is like trying to spread a layer of fine dust perfectly evenly on a wall, make it stick, and do it at lightning speed. It's like trying to compress fine gravel into a perfect mirror. And as of 2025, Giga Texas is finally scaling it. This process, it doesn't just promise to cut factory footprint and energy use by 10 times. Internal reports are already clear. The 4680 cell is already cheaper for Tesla to make than anything they can buy from suppliers. This This is the final piece of the puzzle. You combine this cheap, powerful cell with a structural pack where the battery is the floor of the car, saving 370 parts, and you have the key. This is the only way the $25,000 car is possible. It's the only way the Tesla Semi works. So, the 4680 cell is the heart, but now we talk about the brain. Full self-driving. For years, FSD has been this promising, controversial, coming soon beta. But with version 12, it went through a change as fundamental as the jump from a flip phone to a smartphone. You see, the old way, FSD 11 and everything before it, was a mountain of code. It was a complex, human-written stack. Hundreds of thousands of lines of C++, a giant, fragile rule book. If the camera sees a red light, then apply the brake. If a car is merging, then calculate its trajectory. If it's a stop sign, but there's a pedestrian and the cross traffic is clear. This approach is brittle. It's impossible for a human to write a rule for every edge case the real world can throw at you. A stop sign hidden by a tree. A construction worker waving you through a red light. This is why true self-driving has been almost solved for a decade. So with FSD V12, Tesla did the unthinkable. They deleted it. They deleted over 300,000 lines of that C++ code, and they replaced it with a single end-to-end neural network. This new system was not programmed, it was trained. Tesla fed it millions of video clips of its best human drivers and essentially told the AI, "Watch this. Learn to drive like this." And it did. Now the system takes in raw video from the cameras and outputs steering, acceleration, and braking commands. Photons in, controls out. This is the ChatGPT moment for physical AI. The AI is predicting the next most likely driving action based on all the video it has ever seen. It learned how to creep at an unprotected left turn by observing humans do it, not by reading a rule. And this system is infinitely scalable. To make it smarter, you don't hire 1,000 engineers to write more if-then rules. You just curate new, tricky video scenarios, add them to the training set, and recompile the brain. But an AI is only as good as the data it's fed and the computer that feeds it. First, the data. With over 6 million FSD-capable cars on the road, Tesla has the largest data-gathering operation in history. When a driver takes over, the system flags that video clip, that difficult, snowy left turn, and uploads it to the data factory. Second, the computer. You've probably heard of Dojo, Tesla's custom supercomputer. But here's the Dravexa level update, because as of late 2025, the game has already changed. Tesla realized that having one giant separate computer for training, Dojo, and a different chip in the car for driving was inefficient. It was a bottleneck. So, they're pivoting. They are now focused on a unified AI architecture. New chips called AI5 and AI6 that will do both. They are building their new training supercomputer, what you could call Dojo 3, out of the same powerful chips that will be in their future cars. This creates the ultimate flywheel, a doom loop for competitors. Better AI leads to a better FSD. More people use it, more data is collected, the AI gets better, faster, and their new unified computer spins this flywheel at a speed and a cost no one else can match. This is the only path that plausibly solves full autonomy. And when it does, it unlocks the single most disruptive economic force of all, the robotaxi. A $25,000 car that can drive itself 24/7 and earn $30,000 a year. That isn't a car anymore. It's an asset, and it's one that will change our cities and our world forever. If you want to see that future happen, make sure you're subscribed to Dravexa. So, you have the brain, you have the battery, you have the factory. What do you do with the world's most advanced AI? You don't just leave it in the garage, you put it on legs. This is Optimus. Forget the guy in the spandex suit, that was the prologue. You have to understand, the Tesla bot is not a side hustle. It isn't a gimmick for the shareholders. It is the sum of all parts, the logical, general form. Think about the convergence. The brain, it runs the exact same end-to-end neural net as the cybercab. The AI that learned to navigate a chaotic roundabout can learn to navigate a warehouse floor. It's the same code. It's just learning human physics, balance, grip, walk, instead of car physics. The heart? It beats with the 4680 battery tech. The muscle? The actuators, the motors, the power electronics, they are ripped straight from the Model Y and Cybertruck lines. Optimized for cost, optimized for violence. And the body? How do you build millions of them? With the exact same unboxed, giga-casted ruthlessness we just deconstructed. The progress has been terrifyingly fast. Gen 1 stumbled. Gen 2 walked. As of late 2025, Gen 2.5 is running. It is 10 kilograms lighter. It is faster. It has hands with tactile sensors so delicate they can hold a raw egg without a crack and then pick up a heavy drill without a slip. And this isn't a lab experiment. They are already in the factories, right now, doing the jobs you hate, the unsafe, the boring, the repetitive. That is step one. But you might ask, why legs? Why a complex humanoid? Why not just a Roomba on steroids? The answer reveals the true scale of the ambition. The answer is simple. The world is built for us. Our stairs, our door handles, our shelves, our drills. They are designed for a creature with 2 legs, 2 arms, and 5 fingers. A robot on wheels is trapped on the flat ground. It is specialized, but a humanoid is universal. It fits into our world. We don't have to rebuild the world for it. It can learn to install a car door today, download an update tonight, and fold your laundry tomorrow. This isn't a product. It is a programmable labor force. Musk is betting on a demand of 10, maybe 20 billion units. That is more than 1 for every human soul on Earth. An autonomous worker you can hire for pennies on the dollar, that is an economic force larger than the car, larger than the PC, larger than the internet. This is the end game. So, zoom out. Look at the whole board. Tesla's tech isn't a list of gadgets. It is a single, interlocking organism. The unboxed process builds the machine. The 48-volt architecture wires the machine. The 4680 cell powers the machine. The end-to-end AI drives the machine. And Optimus takes that machine and gives it hands. You see? Each piece is a lock, and the next piece is the key. They aren't trying to sell you a slightly better electric car. They are building the infrastructure for the next industrial revolution. Whether this colossal gamble pays off, or whether society is even ready for it, is the single most important multi-trillion-dollar question of our time. And we will be here to watch it unfold. Thank you for watching Dravexa. If this video rewired your brain, hit that like button, and make sure you are subscribed with notifications on. Because the future is moving fast, and you do not want to be left behind.